Hello and welcome. This lesson is going to be about angles and angles addition postulate, and it's going to be very similar to what we learned when we talked about segment addition postulate. The objectives today is to identify and name different types of angles in geometry and to use the angle addition postulate to establish geometric relationships and to translate those relationships into algebraic equations, which then can be used to solve to find the missing information. So very similar objectives when we learn segment addition postulate. So let's just review a little bit the classification of angles. If an angle has this little symbol here, that means 90 degrees. So that means the angle is a right angle. If the angle is less than 90, then it's acute. If it's greater than 90, is obtuse. And if it's equal to a 180, is straight angle. In order to name an angle, many times you're going to have to use three letters. Let me use an example here. Suppose I have a triangle, and let's call this A, B, and C. These are the vertices of a triangle. So this is vertex A, vertex B, vertex C. So if I was going to name this angle right here, I could call it angle A. I also could call it angle BAC, and I also could call it angle CAB. So if you notice, when I use three letters, the letter A was right in the middle. So there's three names I could name this angle. Angle A, angle BAC, angle CAB. Now let's imagine that I have another segment here inside the triangle. And let's say this is segment AD. And when that happens, then I have three angles. I have this angle right here. I have this other angle right here. And I have the original angle that we were talking about before. So now I have three angles. And if I try to name it angle A, then it's going to be kind of misleading. So in this situation, then I would not be able to use one letter. I must use three letters. Because using three letters, then I can say that BAC is definitely this red angle here. And angle BAD is the one with the two blue lines here. And DAC would be the one with one line. So as you see, sometimes you can use one letter, but sometimes you can't. For example, in this diagram that we're going to look right now, you have to use three letters because otherwise it'll be very hard to say angle J, and we don't know if it's this angle, this angle, this angle, this angle, or combination of two or three other angles. So let's see here about these examples here. So using the figure to the right, classify each angle below. So KJL. And let me go ahead and erase this for now so we can clear this out here. That way we can better see what we're looking at. So KJL. And what I like to do is I start with KJL. So I know I'm talking about this angle here. And basically, what is the classification of that angle? Well, that angle is acute. Then we have MJP, which would be this angle right here. And if you notice, we have a 90-degree angle symbol there. So that means this would be a right angle. All right. Let me erase some of the marking that I made. And now we're going to look for MJN. So let's look for MJN. MJN would be this angle right here. So if you notice, this is less than 90. So this would be acute. And then we have LJP. LJP. So it would be this angle right here. So that definitely is obtuse, bigger than 90. And the last one is KJP. So KJP, so K, J, and P. So you start K and go all the way to P. So this would be a straight angle because it forms 180 degrees. So straight angle. So that's the classification using the names of the angles using three letters, okay? So this is pretty much things that you have should have learned in middle school, but naming with three letters might be something new for some students. So we just want to make sure that we go over it. So over here on the next set of examples, we have a protractor. Protractor is like a ruler to measure angles. Okay, and basically we position the protractor so the center is right here at the vertex. Okay, because as you know, you have a whole bunch of angles right here. And what we're going to do is we're going to classify each angle and identify its measure. Now, let me remind you of something. When we did segments, okay, this symbol right here, AB with a little segment on top, is was referring to the drawing of the segment. Now, when I leave out the segment, then that is representing the measure of the segment. So let's say I have a segment AB. Let's say this segment is 5 centimeters, okay? And so the drawing, this symbol here, AB with the little segment on top, is referring to the drawing. And AB without the little segment on top is referring to the measurement, which equals 5 centimeters. Okay? Very similar in with angles, we have this nomenclature representing the drawing. So what is angle ADB? So basically this angle right here. Well, that angle right there is a right angle because it measures 90 degrees. Now the measure, we're going to use this little m, ADB. And that's how we represent the measure of an angle. So if you see this m with the angle symbol and the three letters, that means the measure of the angle. So that means this angle here, if you notice, go all the way up to 90. Okay. Also notice the protractor counts goes all the way to 80 on top. And here it starts at 0 and goes all the way to 180 on the other side. Okay. It's just the way the protractor is set up to make it easier to read. All right. Let's go ahead and do ADC. So let's see, ADC. AD and C will be this one right here. So if you notice, this would be 120. So that means this is an obtuse angle. And the measure of angle ADC equals 120. Very good. Let's go on to the next one. CDE. So we have C, D, and E. So basically this angle right here. Okay. And we can use it from here. And we see that it's 60 degrees. So we know that is an acute angle. And we write the measure of angle CDE equals 60 degrees. Very good. Now let's go on to the next example, which is AD and E. So basically, we're doing this whole thing right there, okay? So right there, this is the angle that we're looking at. So we notice that's 180 degrees, so that means this would be a straight angle. And the measure will be 180 degrees. So measure of angle ADE equals 180. Sorry. Okay. Also, I want to make sure that you understand that sometimes I use this symbol and sometimes I use this symbol. Both symbols are the same. Many books interchange between the two. The reason why I like this sometimes is because sometimes students write their L might look like the angle symbol because it's kind of slanted. So that's why I prefer to do that. But know that either way is fine. All right, let's angle BDC. So if you notice right there, BDC would be this angle right here. Okay, and here's going from 60 to 90 or 90 to 120. So in other words, there's a difference of 30 degrees. So that means this would be an acute angle. And the measure of that angle BDC is 30 degrees. Let's go ahead and go on to the next page. Very well. Now we're going to talk about complementary angles and supplementary angles. This is something that you might have seen it before. Basically, complementary angles are two angles that add up to 90, and supplementary angles are angles that measure up to 180. One easy way that I remember this information is that C comes before S in the alphabet, so does 90 comes before 180 in the number line. So complementary is 90, supplementary is 180. Okay? All right, so using the figure to the right, name the complementary angle to MJN. So let's take a look over here. So we have MJN, and we're looking for the complementary angle. We also notice there's a 90-degree angle right there. So we know that this angle plus this angle is equals 90. So that means the complementary angle will be this one, MJP. So the answer will be MJP. Very well. Now, let's go ahead and look for, name the supplementary angle to KJL. So KJL, so it'd be this angle right here. And we're looking for something that supplements that. Well, if you remember, supplementary means 180. So that means this will be this angle right here. And the name of that angle is MJP, means LJP. So LJP starts at L, J, and P. Very good. Now, let's go ahead and erase this. And let's look at the next example. The question is, are LJM, so LJM, which is this angle, and MJN, are they complementary? And remember, complementary means 90 degrees. And even though it might look like a 90-degree angle, we don't have any symbol right here saying that this is a 90-degree angle. So our conclusion is that no. Why? Because there's not enough information. Now, we're going to talk about angle bisector. Angle bisector, if you remember, bisector means cut something in half exactly in the middle. And because it's an angle bisector, it's something that cuts an angle right in the middle. And usually is a ray that cuts the angle into two equal angles. So if you look at this drawing right here, we have this ray YW, and it's cutting in half the big angle XYZ. So right there is the example. Ray YW is the angle bisector of angle XYZ. Therefore, the angle XYW is congruent, that's what the symbol means, to angle WYZ. Therefore, the measure, remember M means measure, the measure of angle XYW equals the measure of angle WYZ. So this is a little bit of the language and codes that are used in geometry to represent congruency, and also that one segment equals another. Please remember also that this symbol means therefore in geometry. Now we're ready to talk about the angle addition postulate, which is very similar to the segment addition postulate. Basically, if you have a drawing like this, you have three angles, two smaller ones and one big one. So basically, the postulate says the measure of ABC equals the measure of ABD plus DBC. So basically, it's saying the measurement of angle ABC, which is the big one, is going to be equal the measure of the other two angles. So that basically, you're going to take this one here and this one right here. So basically, you're going to add the red with the blue equals the green. So the big angle equals the sum of the two smaller angles. With that in mind, we're going to go to example number 1. And here we're given a drawing and some information in writing. First thing we should do is change everything into the drawing. So I'm going to put that information right there. VUT is 175. And then it says angle VUJ is 17x minus 3. So what I'm going to do, I'm going to draw right here 17x minus 3, VUJ. And the last one is JUT is 17x plus 8. So I'm going to do here, and I might do 3 little lines. So this would be 17x plus 8. Now that we have that labeled and everything, we're going to derive a relationship. What we can say is that the big angle, which is the measure of angle VUT, equals the measure of the two smaller ones added together. So the measure of VUJ plus the measure of the other angle, which is JUT. And the reason why we can say this is going to be the new law that we're learning, which is angle addition postulate. Now that we have established the geometric relationship, we're going to plug it in the information and we should get an algebraic equation. So angle VUT is 175. The measurement of VUJ is 17x minus 3 plus the measurement of JUT is 17x plus 8. Now we're going to solve the equation. So if you notice, now I have an equation, and the first step of solving an equation is to eliminate parentheses. But we don't have any parentheses here, so let's keep to the second step, which is combine like terms. And that step we can do here, because on the right side, I can combine 17 with 17, and negative 3 I can combine with 8. On the left side, 175, all I can do is bring it down. And 17 plus 17 is 34x. And negative 3 plus 8 is positive 5. Now that I have that, the next step in solving an equation is to cancel the numbers. The only thing that I can cancel here is the 5, or the numbers without letters. So I'm going to go ahead and cancel the 5. And that will give me 170 equals 34x. And that we're going to divide both sides by 34. The 34 cancels. I don't have any space on the bottom, so I'm going to write the answer right here. So this would be 170 divided by 34 is 5. Okay. Don't forget that you have a calculator that you can use. So 170 divided by 34 equals 5. There we go. At this time, I'd like you to try this problem. So go ahead and stop the video. Try this practice problem number 1, following the example 1, and see if you can solve it and find the answer to this problem. When you're ready, restart the video and then we'll see the answer. All right, very well. Welcome back. In this problem, we're given the information that ABC is 17x plus 8. So let's write that information down. We also know that ABK is going to be 42. So let's write that information down. Let me put just little 2 lines right there. And this last angle here, which I'm going to put 3 lines, is 12x minus 4. Since there's not enough space there, I'm just going to draw an arrow here. And I'm going to write 12x minus 4. Now that we have that drawing, we're going to derive the relationship. Please remember, one of the things that we're learning is angle addition postulate, which says the big angle, so in this case, big angle is ABC, equals the measure of the two other angles. So let's see, angle ABK and the measure of KBC. KBC. And the reason why we can do this is because of angle addition postulate. So I have derived my geometric relationship and I have justified. Now I'm going to substitute. the information given. So angle ABC is 17x plus 8 equals, the measure of ABK is 42. The measure of KBC is 12x minus 4. Now that I have that, I follow the 4 steps of solving equations. Can I eliminate parentheses? Well, I don't have it, so guess what? We don't have to do that step. Skip to the second. Second step is combine like terms. Okay, I can do that. 42 minus 4. Let's draw the little border. And on this side, there's nothing that I can combine, so all I do is bring down the information that I see. On the other side, I can do 42 minus 4, which is 38. Bring down the 12. Now I'm ready for the third step, which is cancel the numbers on each side. So in this case, I'm going to cancel the 12x. And I'm also going to cancel the 8. Now that I do that, I cancel the 8, I cancel the 12, and I do this operation. 17 minus 12 is 5x. And 38 minus 8 is 30. Now we're going to divide both sides by 5. So that means my x equals 6. Now, unlike the other problem or the previous example, where we found x and that was our answer, in this particular problem, the answer is not 6. We're not trying to find x. We're trying to find the measure of angle ABC. So let's copy that. Measure of angle ABC. And if we go to our drawing, we see that ABC is 17x plus 8. So let's come over here. 17x plus 8. And this would be 17 parentheses 6 plus 8. And now right there, you can just use your calculator and punch it in. 17 times 6 plus 8 gives you 110. Also remember that your calculator can use parentheses if you like. So instead of using 17 times 6, you could write 17 parentheses 6, close parentheses plus 8. Exactly what you see on your paper. And then you press enter, and voila, as they say in France. And that is our answer. Pretty cool, huh? All right, let's go on to the next problem. Here we have our next problem. We have a drawing and some writing. In the figure, ray KJ and KM are opposite rays. So basically KM and KJ are opposite rays. So that you know, opposite ray means that one goes one direction and the other one goes 180 degrees on the opposite direction. So that means they both form a straight line. And then it says KN, which is the ray KN, so this ray right here, it bisects, okay, that's a keyword right there, bisects the angle JKL, so this angle right here. All right, very good. So with that information that it bisects, I can draw this little symbol right here, and you notice the tick mark, that means they are equal to each other. And then the problem says that JKN is 8x minus 13, and NKL is 6x plus 11. Very good. Now that I have the information on the drawing, I need to look at it and see what can I do. Okay. If you notice, I cannot use the angle addition postulate because I only have two of the angles. I don't have the big one. So that's a big unfortunate event there. But what can we establish? What geometric relationship can we establish? Well, we are given that these two are the same because they use the word bisect. So guess what? We can set up one angle equals another. So let's set up JKN equals the measure of the other angle, which is LKN. And the reason that we can say this is because of the definition of angle bisector. So if you notice now, we're growing into our different laws and definitions that we can use in order to solve problems. So let's see what we're going to do. Now we're going to substitute and see if this equation will be something that can be solved. Okay, so JKN, when we look at the drawing, is 8x minus 13. And LKN is 6x plus 11. Okay, now we don't have any parentheses, so we skip the first step of solving equations. We cannot combine terms, so go ahead and skip the second step. The third step is to cancel the numbers. So this we can do. So we're going to subtract 6x from both sides of the equation, as well as we're going to cancel the 13 and add 13 to both sides. When we do that, the 6x cancel, the 13 cancels, 8 minus 6 is 2x, and 11 plus 13 is 24. We divide both sides by 2, and then we get x equals 12. Now be careful, is that what the problem is asking us to find? When we read the problem, we see that the problem is asking us to find JKL, not the value of x. We do need the value of x to find the answer. So let's write over here JKL. And what is JKL equal to? If you notice, JKL is the big angle. Now there's many ways you could do it. You could do this plus this, or you could do 2 times this one or 2 times this one. Doesn't matter which way you go. I'm going to do by saying that this angle here is 2 times this angle here, NKL. So the measure of angle NKL. And basically that's saying that 2 times 6x plus 11. So that means I'm going to do 2 bracket 6 parentheses. The x is we found to be 12 plus 11. Okay. And there we go. Let's go over here to the calculator. And notice that I use bracket because I'm introducing a parenthesis here. You could have put just parenthesis there. The calculator doesn't have any brackets, so you're going to see that I'm going to use 2 sets of parentheses, and I should get the answer. So let's see. 2 parentheses, 6 parentheses, 12 close parentheses, plus 11 close parentheses. If you notice, that's exactly what I wrote there. And when I press enter, calculator gives me the answer, which is 166. And that's our answer. Pretty cool, huh? All right, let's go on to the last example for this notes. And here we need to make a correction because I should have put here BC. Okay. And let me reduce the view a little bit because we cannot see the whole problem. Okay, so there we go. All right, so we fixed this BC. Now we can see the whole problem. And let's see. BC is the angle bisector of ABD. When I see that, I'm going to go ahead and click and put it right here on the drawing that these two angles are the same because that's what angle bisector is. Then ABD, that's the big angle. So that would be 7x minus 5. Then we have 3x plus 9. So I know that this angle here, actually CBD, is 3x plus 9. So 3x plus 9. But we also know that if this is 3x plus 9, the other angle right here is also 3x plus 9. So let's go ahead and write over there, 3x plus 9. All right, very good. Now, you might want to say that this angle equals this angle, just like the previous problem. But the problem is, if you notice right here, if I said this equals this, will I be able to solve it, or everything would cancel? Well, in this situation, they would cancel. So even though we have the word bisector there, we don't want to set it equal to. What we want to do is, look, we have this angle, and this angle. So basically I have the big angle and the two smaller ones. So let's use angle addition postulate. So let's do angle ABD is going to be equal to the sum of the two smaller ones, which is ABC, plus the measure of angle CBD. And the reason why we can say that is because of an angle addition postulate. And I hope you start to see that as the laws and definitions of geometry become more known to you, you're going to be able to use many of these laws, and you have to decide which law should be used at each circumstance. Okay, and that's what's happening here. We're looking at this drawing and we see that this is the law that's going to help our case. Okay, so let's plug it in, and then we should have an algebra problem. So basically that's the geometry, and now it's going to become an algebra problem. And then it'll be old history. All right. So right there, I'm substituting the value of those two angles, and now I have my equation. First step of solving equation, eliminate parentheses. I don't have any. Second step is to combine like terms. I can combine 3x and 3x, and I can combine 9 with 9. On the other side of the equation, there's nothing I can combine, so all I'm going to do is bring down that information. On this side, 3 plus 3 is 6x, and 9 plus 9 is 18. Now that I have that, third step of solving equation is cancel the numbers. So I'm going to cancel 6x on both sides. And then I'm going to add 5 to both sides. Now that I do that, the 6 goes away, the 5 goes away. 7 minus 6 is 1x. And then 18 plus 5 is 23. Now, do I really need to write the 1? Because 1 times x is the same thing as x. So basically, I don't have to write the 1. So basically, my problem has finished right there, finding the value of x. And let me restate that. The problem is not finished. I did find the value of x, but remember, we need to find the value of the angle ABD. Let's see. ABD, we know that it is 7x minus 5. So instead of x, we're going to put parentheses, and inside the parentheses, we're going to put the value of x that we found, which happens to be 23. And then using our calculator, come right there, parentheses 23 minus 5. And there we go. We got the answer to be 156. So there we go. That's our answer. And this concludes our lesson for today. So today we learned about angle addition postulate. Also, we learn about angle bisectors and different properties of angles. I hope this video was helpful. Thank you very much for your time and have a great day. Bye-bye.